Welcome to Brainstorm 9000.
You got a brain? Your brain wants to listen to this podcast.
So open your brain.
Oh yeah. Oh yeah. What's the topic? Got a rhythm, I got it in my system. And she come and get the licking, she coming with the pinching. I got an algorithm, yeah, I got up in her system. And I gotta get the licking, I gotta get the dishing. Cause she come with suspicion and she coming with the pimping. But I'm here with this pimping and I gotta hit my click up, She like, where your man's at, where your bend at, get your bends up, where them rats at, ooh, I need that cheese, cheddar, guacamole, oh my god, I'm so holy, oh my god, I do the totally, oh my god, I need that guacamole, ravioli, can't speak on this cheese like pasta, but I mix it with the programs in the system like computer and IBM, and I'm going type it in your I fell off the beat again, I'm back on the streets again, I got an algorithm, wait, I got an algorithm, yeah, I gotta do computing, yeah, I'm going so stupid, ooh, I can't curse, but I'm going so stupid that I'm going so ruthless, and when the algorithm figures out my brain, and it drive me insane, cause they got these things on my feed that's so effing lame, like they sell me the same things, the same Jordan, same sneaks, same pouring, same freak, same freak, same freak, same freak, same freak, same team, algorithm get on my feet, It's my garbage freestyle for today.
I love it.
They're only getting more garbage.
Hello everyone, and welcome to yet another episode of Brainstorm 9000. Today, we have our favorite guest, Nicholas, the Google guy. Hi, Nicholas.
Hello.
Vitnell is our god of recording, and somehow I discovered that people like that always kind of stay in the shadow. Nobody knows about them. Hi, Vitnell, can you say a couple of things of how do you record us? What steps do you take so it happens?
Well, the first step I take is to turn on all the equipment, obviously. And then I patch all the mics together. I got to plug in all the mics to their specific inputs that I want to use it. And I have to route it to the corresponding preamps. And then after I do that, then I have to go on the computer and match the inputs so I can see what we're recording, and it will transfer from analog to digitally so the computer can record what's being heard.
That's it?
In a nutshell, yeah, that's it.
Well, Nicholas, doesn't it sound to you as a set of instructions?
That is a very specific set of instructions, correct.
Is there a name for it in your world?
I would call it an algorithm.
Let's ask Siri.
Let's ask her.
Hey Siri, what is an algorithm?
In mathematics and computer science, an algorithm is a set of instructions, typically to solve a class of problems or perform a computation. Want to hear more?
No, thank you. We're going to talk about it ourselves.
That's right.
So, can you explain to me and to the brains of the internet who are not as brainy as you are, what is the algorithm in computer science?
Right. So in computer science, we use what's called programming languages that are a set of instructions that we use to communicate with the computer to tell it what to do in an unambiguous way.
Right.
And anytime we write a list of instructions to describe what it is we want the computer to do, that's called an algorithm. So there's a number of algorithms. They're very simple ones.
Right.
That you can use to find the shortest path through a map, for example, to very advanced algorithms that can detect patterns in images, for example, which is something that we're doing. We've gotten a lot better at more recently
Thanks to Fei Li, right?
Yes, thanks to a lot of people.
Right.
And we use it to do facial recognition, to OCR, optical character recognition.
What does that mean?
So that's if we scan a document,
Right.
it'll take the picture of the document, and there's an algorithm to extract the letters from that document so that it can be readable by a computer.
Sounds scary to me already. So I remember back when I was still in Moscow and I was struggling with reading complicated EEG. I had a thought back then that it would be nice to formalize the analysis of the EEG. I have to tell you I didn't succeed much because it was only me. But nowadays, in my practice, I use what is called quantitative EEG. So somebody created a program that compares somebody's EEG to thousands and thousands of standard EEGs, and then recognizes a pattern and analyzes it and presents the data as a picture, where green means good, like everybody else, red means an excess of something, and blue means not enough. So in order, but I started doing this, and at that time we had a mainframe computer that I had access to through my friends, and mostly through a parent of one of my friends because I was very young. It was called Nairi. Don't ask me what it means, it's just a name.
What was it called?
Nairi.
Naivi?
Nairi. Nairi.
Okay.
Just a computer. And the terminal, so I had to code it in zeros and ones. So I guess that was the beginning of algorithms, right?
Right. So that's the goal, right? So if you think about a computer,
Right.
Well, what is a computer really? It's just electricity, right, running through a circuit board. And the only thing you can do with electricity is either have it go on
Right.
or off,
Seriously.
right? So that's 0 or 1.
Wait a second. So any computer, when it works, it's
Right.
either on and off.
Well, no. So that's your circuit,
Right.
right? And the computer chip is
Yeah.
made of millions of circuits, right? So then we've got a series of ons and offs, right? That means something,
Right.
right? We assign meaning to those things, but really all we're doing, right, is turning. It's almost like flipping a bunch of light switches on and off, right? And we say, okay, if this light switch is on and this light switch is off, we're going to interpret that to mean the letter A.
Right.
If they're both on, then we'll interpret that to mean the letter B,
Right.
right? So, but thinking that way,
Wait a second.
Right.
But this is a binary code you are describing.
this is binary code. That's
Well,
correct.
but if it's only 0 and 1, we have only two letters, A and B, right?
Well, if it's only 0 and 1, that's correct. But you take a lot of these switches and you line them up together,
Right.
right? Those are called, each one of those is called a bit,
Mm-hmm.
right? And a bit can be in one of two positions, a 0 or a 1,
Right.
right? A 32-bit computer,
Right.
every instruction that you pass the computer is made up of 32 bits.
Minus 64.
Right. So you can have 2 to the power of 32 different instructions represented in a single in a single byte.
But my computer is actually 64-bit. So
Right, so
yours
nowadays-
probably also, right?
Yeah, mine's a 64-bit.
Right.
So
it's 2 to the power of 64.
that's correct.
That's a crazy number.
That is a crazy number. It's very,
That's,
it's very
that's,
large.
that's
And
64 zeros, right?
right. Yeah, and that's bigger than that's one instruction.
Right.
And computer programs are made of a number of instructions.
Wait a second. So in
Right,
a
so-
64-bit computer, each step of an instruction is described 2 to the power of 64?
That's right. So that's how many instructions we can fit in that one step. What that actually means is that's the number of bits that the computer can operate on
Right.
simultaneously, right? So in parallel.
Mhm.
So we'll call that like that's like a double byte or a double word. But so each one of these things has names in computer science.
Like what?
But the point, like you have your bits, your bytes. Like a byte is going to be 8 bits.
Right.
A word is like 16 bits,
Right.
right? 4 bytes is 32 bits. 8 bytes is 64 bits. So it gets bigger and bigger, and the more not only does that represent the instruction, right? Typically, instructions will have arguments to them, right? So you have something that represents the instruction, right, which is going to be some 64-bit number represented in zeros and ones, and that's operating on a piece of data that's also referenced by a 64-bit number. Right?
By the way, you work for Google,
Yep.
and it's spelled Google. My understanding is that it's actually misspelled because originally they wanted to call it Goog, I think OLE, because it means something in mathematics.
A Googleplex.
Right. And they were looking for an investor, and they found one who gave them actually a check for $100,000. They were very happy, thanked him, and then when they came out of the meeting, they saw that he spelled it Google.
So they had to change the name. That's fascinating. Yeah.
You do know that story, right?
No, that's the first I hear of it.
Yeah, I read about it actually in multiple places, but one of the places where I read it was a book that is called Formula, which I highly recommend. It's all about algorithms and how they run our life. And this is one of the reasons we are meeting, because I know you haven't read the book yet, but it makes it even better, because I would like to run by you a couple of ideas. So you were saying that basically in the modern computer, and I'm presuming that 64-bit is the top of the line, or
There's 128 bits.
Really, 128?
Yeah.
Is there anything higher?
I mean, there definitely can be. There's specialized hardware that goes higher than that. We have now things called vector unit processors that can process much wider. We call that the width of the number. We can process much wider numbers, so we can do more operations in parallel. There's tricks in order to make it seem like you're doing more things in parallel when really you're just operating on a much larger number.
Oh my God!
Right. So it's all about to write things in zeros and ones.
Right.
Right. Is to express ourselves that way isn't very expressive.
Right.
Right. So what we've done is over time we've abstracted those zeros and ones, right, into things that are more tangible, right, and that are easier for us to understand and discuss and to write down and more meaningful to read. So things like, if this is bigger than this, then do this.
That's how you write your program. Like you literally write if.
We'll write if, and then there's, depending on what programming language you're working in, most of them have, that's called a conditional statement that has an if, a then, a loop, some kind of looping construct where you do this a number of times, or you do this block of code, execute this block of code until some condition is met. That's called a loop. We've got while loops, like while this is true, do this. That would be common, like if we were monitoring a file system to see if you've saved anything new, right? Or if you added anything to the file system, we might
it
have
happens
a loop.
to me all the time.
Yeah, we'll have a loop that's sitting there looking at because we don't actually know, right? But we'll have a loop that checks to see if there's any new files, and then we can go to sleep, right? To say, okay, well, let's pause this program for a couple of seconds and check again, and that'll work in a loop. Your operating system, Windows, Macintosh, Linux, is one massive loop, right? That gets input, does something with it, right? And then displays.
Okay. While you were talking about this super smart stuff, I decided to look up the actual history of Google. And actually the original word was Google, which is Googol, which apparently means the number 1 followed by 100 zeros.
Right.
Which, I don't know who can imagine this. Can you?
I think that was the point.
Right. So, but then as I said, the guy misspelled it, and that's why now it's called Google and sounds just fine to me. So, loop I understand, because every time I save a file which I create, let's say in Word, my computer asked me whether I would like to replace the same file with the new version of that file. So what you're saying is just sitting there and monitoring.
Right.
Right. So all the computers basically work only after somebody like you or people who work with you create a program and basically give detailed instruction to a computer, correct?
That's correct.
That's software.
That's software.
So a computer itself has zero freedom.
That's correct.
At least for now. So when I ask Siri, this thing has to basically loop and loop and loop and loop, or what? Like
so Siri is constantly in a state of looping,
right,
waiting for you to ask her a question.
Okay.
Right, and when you ask a question, right, she gets activated.
Right.
Right, there's going to be somebody. It's several programs working in conjunction with one another.
Right.
In order to produce the result. The first thing that's going to happen, all right, is there's a natural language processing program
Right.
that is interpreting your words, similar to what I mentioned earlier with OCR, right? It's taking your spoken word and trying to identify what words those are written down, right? Because the computer doesn't know what to do with an audio file, which is essentially what you're doing when you're speaking to it. Right, but what it can do.
Wait a second. So it records me real quick and then analyzes it.
That's what it's doing, right?
Oh my God! Like in a few milliseconds, it records and then listens to it again.
Yeah, it has to. It's called it's buffering, right? So it's going to buffer. It's going to give it a buffer, some maybe a 30-second buffer,
right?
Where it's recording what you're saying, and then it's going to analyze that, and the output of that. Most programs have an input and an output, right? So in this case, the input is going to be your speech, the words that you're uttering to Siri, and the output would be your the words that you spoke written out. And then somebody's going to take that and run it through a disambiguation program, right? That's going to try to assign meaning to the words based on the context in which you uttered them, right? So things
meaning like zeros and ones, essentially.
Not yet. Well, all of this is done with zeros and ones. When you write a computer program, right, you're writing it in this high-level language that's easier for us to understand. And the point is that it's unambiguous, unlike the human language or English or human languages, which are very ambiguous.
But it's written in English always.
Right. Mostly, yes. So I used to work. So I haven't worked in every country, but I used to make video games. We used to get hardware from Japanese companies,
and they write in Japanese.
The comments and the documentation is written in Japanese, but the code is written in English.
Right. I know that in Russia, they write the code in English.
Right.
And a lot of my friends who are computer engineers and started from writing the code. When they came here, they had no, like they didn't speak English, but they had no problem writing code because they knew these words that you guys use. Like, for example, I remember C++, there is a language like that, right?
Yeah, C++ is a language.
Which is probably outdated by now.
Well, people, we still use C++ at Google.
Right.
Right. The search engine is written in C++.
Right.
I believe. We use a lot of different languages. Google. C++ is one, Java, Python is another language we use. One of my preferred languages is not very widely used at Google. It's called Lisp, Lisp.
But is it the common language that people can learn?
Anybody can learn it. It's a little more difficult to learn. It's actually a smaller language.
Right.
At its core, I think there's only 11 different instructions.
Really?
Right.
You can write a program using 11 instructions?
Absolutely. Right. And it was designed to be, we call, when a programming language can be used to solve the set of known solvable problems. Right. We call that language Turing complete. Right. So that's a Turing complete language, meaning
Turing, like the guy? Turing?
Named after Alan Turing.
Why?
Because Alan Turing expressed algorithms, right, in a very interesting way. His thought experiment
Right.
For algorithms was imagine a machine,
Right.
right, that had a piece of tape, like a long piece of paper,
Right.
right, and on that paper, right, it's infinitely long. This
Right.
paper, right? There's no limit,
Right.
right, and we can write, and we'll say, you know what? We'll say there's two pieces of paper,
Right.
right, and we can write on that paper any symbol that we want.
Right.
We'll call those symbols that we're using the alphabet,
Right.
right? It doesn't have to match any known alphabet, right? But you can make whatever symbols you want,
Right.
right? And based on the symbol, right, we're going to take that tape and run it through this machine, which has a reader head, and it can read one symbol at a time. And based on that symbol, it's either going to write on the other piece of tape a different symbol,
Mm-hmm.
right? Or, any symbol you choose, right? But it's going to be the same, right? Or it's going to move the tape a certain number of steps. And given those things,
Right.
those operations,
Right.
we can construct, that's a Turing complete machine. That's the minimal set of things we need to express anything that a computer can do today.
But such a machine does exist, or it's something
It's
that we are
a
striving?
theoretical, no, it's
Yeah.
a theoretical machine. It's very inefficient.
Right.
But every language, every algorithm, every program we write can be transformed into something that can be expressed on this Turing machine with the long piece of tape that with these crazy symbols on it.
Right.
And that's called a Turing complete. That's called a Turing machine.
Right.
And those languages are called Turing complete if they can be transformed into something that theoretical machine can produce.
By the way, for people who have difficulties recognizing the name, remember there was a movie, An Imitation Game, or probably The Imitation Game.
Imitation Game, yeah.
That's about Alan Turing.
Yeah, it's a great movie. I
Yes.
highly recommend it.
Yes, me too.
He had a very interesting life,
Right.
and I won't spoil the end for you, but see it all the way through to the end. It is
Yes.
a great, great, great film.
Yes. So no spoiler alert.
No spoiler alerts on this one.
Right. So I cannot possibly even imagine that I would be able to express anything I want to say or anything I want anybody to do using only 11 commands. I know a bunch of men who probably would use only 3 or 4, right? Because they would say food, right?
Right.
Sex, baseball, football, beer,
Maybe sleep.
sleep. What else?
That's about it.
I-
Those are all the basic necessities.
We are not shaming or disrespecting any man. The both of us are men.
Oh,
Right?
fight, right? We fight sometimes.
Yes.
Well, over beer or sex.
Yeah, well, in my age group, we don't fight. Right? We try to negotiate.
Then you need more commands.
I'm pretty sure that women have significantly more words they need, but like when I started listing these things, it's actually kind of simple. I have 2 cats, so for them it would be also pet, meaning like pet me,
Yeah.
and that would be probably it.
See, but the problem is that these words, right? We say food,
Right,
right? They're ambiguous, right? Because it implies a lot of things. Are we making food?
right,
Are we eating food? What kind of food are we making?
right,
The problem that one of the challenges with computers is when you're writing an algorithm out, you have to be very, very precise and specific.
right,
It's easy for the computer to do mathematical feats that we can't even imagine to do ourselves.
Well, I cannot imagine anything beyond the multiplication table, which actually, because I'm 64, I remember by heart because they made me,
Right.
right? So 8 times 8 is 64. I
Right.
remember that, right?
But a computer, you ask a computer, you say something simple. You and I say, walk to the corner,
Right,
right? It
That's-
struggles with it, right? Because walk is ambiguous.
right,
The corner, what corner? What's a corner?
right,
Right? All of these things would need to be defined. The program to describe walk to the corner and then walk. How do you walk? So much goes into walking, balance, moving our feet in order to move forward. They only recently came up with algorithms that can make a robot walk efficiently like a human does.
We are recording this program on the 29th of August, year 2019, and most of the people don't even know that the very last spaceship that went to the station that is orbiting our Earth, right, actually had a Russian robot whose name is Fyodor. Don't try to pronounce it, or don't even ask me to spell it. I mean, I'll spell it for you. It's it's Fyodor, but you say it Fyodor probably, right? But it's actually Fyodor.
Like Fjord?
Yeah, but it's Fyodor.
Okay.
But it's Fyodor. It's a very typical Russian name. It's like people know a Russian name Ivan, so it's even like worse, right? Meaning,
Okay.
but it's a very cute name, and Russians criticize it quite a bit. And one of the things that they're saying, and I don't know whether it's a joke or not, that the next one that they're going to send there is going to be without legs. I don't know why, but I remember a Japanese robot who actually met with President Obama. Remember, and they were bowing to each other.
Was
And
it Osimo, probably?
Yeah, it works in a very bizarre way. Most of them work in a very strange way. But in Boston Robotics, they have a robot that fights and even throws like kung fu leg fits and stuff like that.
Yeah, those are some of the more recent advancements that we've had in walking and movement. It's the things
speaking is easier
speaking
for the robot.
Yes, right now we've mastered speaking, as you can see with Siri.
Right.
Before we mastered walking. Yes, that's correct.
How come?
That's weird. So what is speaking?
Right.
Right. So speaking, right, is given a script, right? Can I utter, the sounds or the phonemes that make up language to sound like a word,
right?
And that we can do. The coming up with the script to say,
right,
is a lot harder. But like Siri is highly scripted, right? She's not actually saying a lot of things that are. It's almost a trick of AI, right? She's not actually thinking, right? She's going back into a database,
of course,
right, and pulling out a sentence and filling in the gaps.
I actually can tell you that I've noticed that in a weird way, certain things you ask Siri, it tells you, for example, about the algorithms, but there are ways to ask a question in which it's going to refer you and say, I found something on the internet, read it, meaning it doesn't say it, it kind of expects you to click and start reading yourself. I've had it in a previous episode, actually.
Right.
On more than one occasion.
That's correct.
For example, we can try it right now and see what's going to happen. Maybe I'll trick Siri into not reading to us. Hey Siri, what is supercalifragilistic?
Okay, I found this on the web for what does supercalifragilistic. Check it out.
See? So then it's showing me supercalifragilisticexpialidocious, and if I click on Wikipedia, it brought me there. See?
Right.
And then I have to read myself. So I'm guessing that it's programmed in a way that things like supercalifragilistic, which is from Mary Poppins, the old one.
Yep.
I highly recommend.
I remember it.
For the brains of the internet to watch it. Because I'm discovering that people haven't even seen the Blues Brothers, actually.
Oh,
the
that's
original one.
Unfortunate.
The millennials. Yes. Hello, millennials. So I guess if the question is common and frequent, or it has anything to do with math or programming, Siri, in quotes, knows how to say the answer. And if it's something esoterical like supercalifragilistic, then it finds it, which, by the way, is amazing because I do have a Russian accent. I do guarantee you I didn't say, and I'm not going to say right now, supercalifragilistic in the most perfect of the ways. Amazingly, I know one word in German that I have no accent in, Studentenheim, which means a dorm. Siri. Hey Siri. What is Studentenheim?
Okay, I found this on the web for what is the devil time. Check it out.
So there's a few things going on there, right? I don't know if you remember when you set up your phone for the first time.
No.
right? But when you set up your phone for the first time, it asked you to repeat certain sentences. It said, it says,
like the very, very, very first time?
yeah. Yeah, it says, read this sentence.
Meaning my iPhone 4?
Whatever. The phone
This
is
10X.
I just wiped my phone recently.
Right.
I had to set it up, and it still asks you, it says, hey, repeat these sentences.
Okay.
What it's doing, it's mapping your variations of words, right, onto what it knows, right? So it's saying, so it has something that it can verify,
right?
Like the dog walked down the block. It knows that's what you're trying to say,
right?
So as I say, the dog walked down the block, if I have an accent,
right,
it can work through that accent because it knows what the intended outcome should be.
So you're saying that it asked me to repeat certain phrases?
It's certain phrases that it's using to disambiguate your language.
This is crazy.
Right? It's
very advanced.
It's actually a form of machine learning. We call it supervised learning, right? Where the supervision, right? It's a family of algorithms called supervised learning, where the supervision is there. You have the expected outcome. You know what it should be.
Right.
And you're just mapping the inputs to that expected outcome. Is that the correct thing or not? So it's very quick and easy. It's one of the easier problems to solve in AI or machine learning right now is supervised learning.
So I can see it very clearly that, of course, if it's expecting me to say something and it knows that I'm saying it, but in a weird way, it can figure it out. I wish some humans could do it because I'm telling you seriously that on multiple occasions, I encountered situations, and here am I doing a podcast with you, right? When people in real life do not understand my English in the United States.
Right. Well, the other reason for that is Siri was, and I can only guess. I don't know anything about how Siri is built. If I built Siri,
right,
which I could,
right,
of course, right,
of course,
I could build it on the way home. No, I'm just kidding. No, if I built Siri, I would have trained it,
right,
with millions of samples of people speaking, which I would have done an unsupervised learning path to cluster those people.
Right.
So I would have people of all different nationalities from all over the world saying these sentences, right, and cluster them together. And what that means is the ones that speak in a similar way would be clustered together. Then you average that out, right? And it's when you speak into it, what it's doing is trying to map you to one of those clusters. It's called classification. And then from there, it knows, oh, he's speaking with a Russian accent. I know how to interpret a Russian accent because I've heard that a million times. The people that you run into in the United States may not have heard so many people speaking with a Russian accent, so they have a harder time doing that.
Well, I would be very surprised because I encountered this a couple of times through my life, but I worked in a place with a bunch of pretty intelligent people, and the guy who was actually running the show wasn't a doctor, who was super smart and looked like almost an exact copy of Tommy Lee Jones.
Okay,
and
interesting.
Even had an attitude of Tommy Lee Jones. Who, Tommy Lee Jones graduated Yale. He was a roommate of Al Gore.
Oh wow, okay.
Yeah. So. And when he just met me for the first month or so, he would make an effort to understand me. And I think I speak kind of fluently. I understand that I make a mistake here and there. And I stopped correcting them because I still have an accent. So if I start speaking perfect English, it's going to be kind of weird. Maybe not. I don't know. But I would presume that the human brain today, at least, is more sophisticated than Siri. But apparently it's not tuned up as well as Siri is, right?
Well, and I think that's one of the interesting things about the development of algorithms and these things. The human brain has some challenges to it, some inherent flaws. We'll learn things and overcompensate. And sometimes it's difficult for us to unlearn things. So if he has overcompensated for English American accents,
Right.
and he's got a lot of other things going on in his head, it may be difficult for him to unlearn that accent to make room for the Russian accent.
It's actually even worse. I can tell you, and I'm presuming, again, today, that computers have no emotions. We don't know for sure.
Not yet.
Well, we don't know that, right? Let's be honest.
Well, we do know that it doesn't have. Well, it depends on how you define emotions.
Like, for example, can computer be anxious?
So a computer right now today can simulate anxious, right? But I think of emotions as an internal state,
Right.
right? That's
Of consciousness. And the thought today is, at least from what I've read, is that what AI offers us, meaning computers, is intellect without consciousness. Although nobody has defined what intellect is, and it's very difficult to define consciousness.
it is.
I mean, people spoke about what intellect is. For example, what was the name of the super famous British physicist who was in a wheelchair and had to use a modulator to speak?
Well, I can't remember his name right now. Come on. We know this. I don't remember his name. That's unfortunate. It's because I have too many things in my head right now.
Well, I'm going to find it out actually much faster than you think. His name was Stephen Hawking. And what he said famously was intelligence is the ability to adapt to change. Okay?
Okay.
So AI can adapt to change yet or no?
We
It
can, yes.
Okay. Consciousness is more complicated. So consciousness, the best way to describe it, and we are going to have a program about consciousness, just not today. It's a very complex issue. But basically, we people have consciousness. We have an inner dialogue going on all the time, right?
Mm-hmm.
So we are aware of what's going on all the time, and we process it all the time. So presumably, computers have intelligence. AI has intelligence. Does not have consciousness and emotions, right?
That's correct. Now there's an interesting theory that in order to build AI that can reach human level intelligence,
Right.
but to get that consciousness, we need to have what's called an emotion-based machine, right? That can simulate real emotion and have that internal autonomy to make decisions off of that emotion. So a famous man, Marvin Minsky, wrote a book called The Emotion Machine.
Yes.
Which he was.
I have it on my list. I haven't bought it yet because I'm reading other books like Formula.
Yeah, and he was Ray Kurzweil studied under Marvin
Yes,
at
I know.
MIT,
Yeah.
and it's a very interesting theory. It's one that I happen to think holds a lot of merit.
Really?
That's right. Yes.
So let me ask you a question. Imagine that you are afraid of, like, what are you afraid of? Anything? I don't know. Heights, dentists. What are you afraid of?
I'm afraid of nothing.
No, seriously though.
I fear nothing.
You are not afraid of dentists?
No, I mean, what is there to be afraid of?
Pain.
Pain is temporary.
Yeah, but when let's say that you are in the middle of experiencing pain and someone comes to you and asks you to do math, you'll probably ask them to wait a little bit.
That's
right?
correct.
Right. Or let's say that a person is extremely anxious, also cannot have a clear head and make decisions.
That's correct.
I can tell you, for example, I read in one of the books about the following situation. Actually, I think I read it in Harari's book, Homo Deus. Where he describes a situation when a pretty famous journalist, a female, went to the training center where they train snipers. And first they allowed her to use a simulator training app, like a video game, in which she had to shoot terrorists, right?
Right.
And she missed like 50% of them she wrote that she would kill one and 50 more would pop up. And then they put on her a brain stimulation helmet. We are talking about year 2012 or 2013. And she all of a sudden felt very clear-headed, and she attained a 100% accuracy. She says that when she then woke up the next morning, she was craving to repeat this experience because she's never had her head so clear without any interfering thoughts as she had during the process of brain stimulation. I can tell our audience that brain stimulation, devices are available. You can even buy them on Amazon.com. I don't recommend it, but we do begin to use them for treatment of anxiety disorders. So we do use other technology, different technology. We'll talk about it at some point. We actually have a program already recorded, and you can listen to it about neurobiofeedback. But my point is that if a computer has emotions, it's not going to be able to make decisions as clear-headedly, so to speak, as it does now. So it'll start missing targets. Don't you think so?
Well, if it has human emotions, yes, right. But what are emotions, right?
Wait a second. Let's ask Siri, my favorite person on earth. Hey Siri, what is emotions?
Okay, I found this on the web for what is the motions. Check it out.
Okay, so it
So
wants.
she had a hard time with your accent.
You think?
She
Okay,
said the
ask
motions.
Her. Ask her.
How do I activate Siri on this one?
Okay.
How do I?
No, just Bruce.
Hey Siri, what are emotions?
Emotion is a mental state associated with the nervous system brought on by chemical changes variously associated with thoughts, feelings, behavioral responses, and a degree of pleasure or displeasure. Should I keep going?
So emotion is a mental state associated with the nervous system, right? So emotion is something, is a state,
Right.
right? Mental state. So in a computer, we could correlate that to the state of the program, right? So
Right.
there's some state that we go into
Right.
based on internal stimulus, right? Something that I am thinking or feeling, right? In a computer, it could be.
I'm sorry to interrupt, but it doesn't have to be an internal stimulus. It could be an external stimulus. Like, for example, you are walking in the jungle and all of a sudden you see a snake. You get scared. That's
I see
an
it.
emotion.
So it's triggered by an external stimulus.
Yes. Or could
Right.
be triggered by both
By both.
external, or it could be triggered by a thought. Oh my God. It's 6:20 already. And my date is 20 minutes late, let's say, right? What am
Right.
I going to do? And then you become anxious or angry, depending on who you are and what your psychological makeup is, right?
Correct. So, I think the interesting thing from an algorithmic standpoint
Right.
would be if we can take something like that from an emotion, like a computer could be monitoring its internal state. It's hot
Right.
in here.
Right.
I feel hot,
Right.
right? So I need to cool down,
Right.
right? And the way to cool down is to process less information, so my CPUs don't run hot,
What is CPU?
right? So my processors, central processing units,
Uh-huh.
right? That's what makes a computer. It's like the brain of the computer,
Right.
right? So and when it runs and it's processing, it gets really hot,
Right.
right? So if it's monitoring its internal temperature, that would be similar to us monitoring our internal emotions and taking action based on that. Another interesting thing would be in the case where you're running late, I feel anxious
Right.
because I'm running late.
Right.
So I'm going to take an action based on that. And I think the interesting thing
You are
about
talking about the computer, right?
I'm
now.
talking about the computer. So if being late makes me feel anxious, I could say, okay, I have an anxiety level, or we'll just call it a number that represents how anxious am I.
Right.
Where 5 is normal, right, and 0 is not is super cool, cooler than normal, and 10 is very anxious. I'm a
Right.
very anxious person. I could trigger anxiety based on some stimulus, right, and that would feed in as input into the next part of the program, the next algorithm,
Right.
which would not just say, which would ask, what should I do next?
Right.
Right. As a computer, what is my next move?
Right.
Right. And I say, oh, well, I'm anxious. Well, what am I anxious about?
Right.
And I think the difference with a computer is we'll be able to reset that anxiety immediately, wherein with people, right, it takes some time and it clouds our thought process.
Takes some time. I can tell you that as a psychiatrist, 50 to 60% of what I do is deal with people who have anxiety disorders
Right.
that they cannot reset actually because something goes out of whack. And we are slowly beginning to understand how it works. But, before one of the main authors, I'm not going to mention the name, who's written a number of books by now, used to say that it's all in our older brain, was talking about amygdala. Amygdala in ancient Greek means amont, and it's a formation inside of our brain, the older formation that is the size and the shape of an amont that triggers fright or flight or freeze,
Right.
like in squirrels, reaction. Now, he finally admitted that our cortex, especially prefrontal cortex, meaning the thing that allegedly we think with, is involved. There are different schools of thoughts. Some people feel that the entire brain is involved in everything. Some people say that, at least myself, maybe there is software. 99.9% of my colleagues don't believe there is software.
Well, you know what? I think that's interesting because everything that you just described to me is algorithmic, right? So
Right.
which by definition is software,
Right.
right? All software is, it's like science. It's a way for us to understand and explain things in a predictable way.
Right.
Why does a ball fall when I throw it in the air? Right? We came up with gravity, right? And then as science, it's a working model,
Right.
right? That we can use to predict how things are going to behave. And I think
Meaning if we throw the ball, it's going to fall sooner or later
that's correct,
because of
right?
gravity.
Because of gravity.
Yeah.
And then we have new models,
Right.
based on, string theory, M theory,
Right.
right? That oh, well, gravity's not what we thought it was. Or that only works on the large scale, not on the micro, on the nano scale.
Yeah, but going back to algorithms, what you're saying that basically what our brain uses most likely is also a set of sophisticated algorithms.
What I'm saying is that algorithms are a term that we use as people to describe a set of instructions on how things work.
Right.
So if we can describe how our brain works as a set of instructions,
Right.
then it's got algorithms.
Well, we can't. Actually.
Right. Well, I think one day we can. And I think that's one of the interesting things that we often miss when we talk about AI, right, is that it's going to help us validate some of these models that we have about human behavior and how the brain works,
Right.
because we'll be able to code it
Right.
and see, does it behave like a human, right? And then we can understand better about human behavior. We can start to tune things like, well, okay, if we tune this part of the model down, anxiety level,
Right.
does it have the expected impact? Does it now behave like a person with no anxiety? And then we can see if we've gotten the model right because it behaves in a predictable way. The same as any other science.
Well, the problem I have with what you said is this. It sounds very interesting, but let's talk about walking, right? Humans walk in a very, or animals, it doesn't really matter, in an extremely sophisticated way. Like, for example, when my cats walk, oh my God, it's very complicated. Yes, they walk on four, not two, on four legs.
Right.
I don't know that it's easier to walk on four than on two, as far as coordination is concerned. Besides, they have tails, and these tails are up in the air and apparently help them to balance.
That's correct.
Besides, the tail very frequently looks like it has life of its own, actually, but it doesn't.
No, it doesn't.
It does have a function.
Yep.
When the cat sits, the tail goes in front by the paws, right? It's so complex and so sophisticated. I guarantee you that the four-legged, and they are robot, some of them look very scary.
The Boston, the ones from
The Boston one,
Oh,
for example,
yeah.
right? And then I think Russians also have a four-legged. I mean, everybody has them by now. I can grant you that they walk using a totally different from human technology, correct? I mean, they have motors inside. We don't have motors, right? Their balancing system is probably significantly more primitive than ours. We have
So a motor is a servo, right? A servo, right, is used basically for, you can use a servo to extend a joint,
right.
or contract a joint. So a servo would behave would be analogous to a muscle.
Yeah, but I can tell you that, for example, if you think about our brain, and we've all seen pictures, and if you don't remember, just Google it, and you'll see that it has a larger part, and then it has a smaller part, like as if there is a small brain attached to the big brain. It's called cerebellum, which literally means a small brain. And it's 20% of the big one, and most of the stuff that it does, not only, but most of the stuff that it does, it's balance, positioning, right, and movement.
It's very difficult.
It's apparently extremely difficult and sophisticated.
That it is.
And then if I were to believe that dinosaurs were a real thing on Earth, right, and not just somebody's imagination, think about how they walked. I mean, they were gigantic. Some of them allegedly had two brains, one in the head, which was very small, and another one is by the tail, right?
Okay.
I mean, this is very complicated, sophisticated stuff to coordinate.
It is.
So no matter how much we model, how are we going to know that our model is identical to us?
We're not.
Right.
Right. It's the same way we don't know. Right. But that's how science is. We never know when we have it right. Right. All we know is that we have a working model.
Right.
Right. That is predictive. So we can use it because it's predictive for certain things.
Right.
Right. We use the working model of gravity, which we now know to be wrong. Right. To send rockets into space.
Right.
Right. So it allows us to advance. It allows us to do things that we couldn't do before.
Right.
And I think coming up with working models for the brain through artificial intelligence and algorithms and simulating things using computers will allow us to make progress in your field, hopefully, and just in understanding and learning and in human development that we were unable to make before. And perhaps once we've made that progress, we'll realize that that model was wrong, and we'll come up with a better one so we can progress even further. And one day we'll have a model that closely approximates how we work, but it's going to take time.
Right. So maybe we can let our listeners to process what we just said. Okay, the brains of the internet, and maybe we can discuss whether algorithms are involved in our life, like day-to-day life already, in our next episode. What do you think?
Yeah, let's do it.
Okay, people. For now, keep your brains
Wide open.
Okay, let's take a break.
Oh, yeah.
Throw some sauce on top there, Dr. Schwartz.
What should I do?
Throw a little ad-lib there. So we did some learning and we did some things about the algorithm. Yeah, we made it sing and we learned the ways they figure out our brain, and we learned the ways that we can change the lanes, and then we make decisions, and then we make our rhythms, and then we ditch the system, and then we make it free, and then we come for free. And yeah, I came for free. This Bryce Hermes with Ed and Nico, and we got a free show called Brainstorm 9000. Yo, he goes crazy with the freestyle flow. And we back your note every week at the same time. Catch the joke. That's the show is done.
Oh, yeah.
Thanks for tuning in to another episode of Brainstorm 9000. If you like us, love us, or marginally tolerate us,
And definitely, if you hate us,
then go on social media and give us a review on Stitcher, iTunes, or YouTube, or wherever you listen to us.
and remember, keep your brains open.